Start that one. Want to read it?
Me?
Mm-hmm. Cassidy, the question?
Leanne and Colleen have the same reading assignment. So far, Leanne has read 90 pages and Colleen has read 126. If Leanne can read 30 pages an hour and Colleen can read 24 pages an hour, how many hours will the library on the same page?
We want to know when will Leanne and Colleen, right, be on the same page? When will they be equal, right? Leanne has read how many pages? If you haven't done this, do this with us, so you'll have 25 done, along with the odds on this assignment. So Leanne has read, Cassidy, how many pages?
Leanne has read
90. Plus, if we are looking at that, Jeffrey, how many pages an hour is she reading? 30. So we're going to put 30, and we're going to put H, because we're trying to find out how many hours, correct? Okay. Next, Haley, what do we know about Colleen? How many pages has she read?
127.
126, is it? Plus, is it 126?
Yeah.
Yep. Plus, what do we know, Kara? How many pages an hour is she reading?
24 pages.
24 each. First step is you want to get all the variables on the same side. So take your feet off the bed. Take it all the way out. There you go. So we want to get all of our h's on one side. What would you do, Hunter, to get all the variables on one side?
Minus 24.
Okay, minus 24h.
Yeah.
Okay, so make sure you're keeping that variable with it. We're going to subtract 24h. So everyone should be doing this in this question, right down here as we finish. So we are looking at, if we look at that, Morgan, we're going to have what?
90.
Now here's a mistake that I've seen a bunch of people doing. At this step right up here, people will subtract 126 from both sides. Okay, and that's wrong. You do not want to subtract the 126. You actually do want to subtract. Don't do it in the same step. Most of you are not yet at the point where you are expert solvers of equations. So don't combine steps. It's throwing you off and getting the wrong answer. How are you writing this down? So we now have 6h, if you need a calculator, but if we subtract 126 minus 90, we get 36. Riley, you with us? What'd you get, Ben? What do we have to do? And we want to do it on both sides of our equation. So Grace, we should have it how many hours? 6 hours, right? In 6 hours, they were both read the same number of pages, right? Questions. Today we're doing the same type of stuff, and I think we're going to get these special solutions. Do you not have your notes? Oh. Special solutions. All equations that we've solved so far in this unit have had one thing in common. They all had one solution, okay? Every time we got like x equal or y equal the number. It might have been a fraction or a decimal, but every single time we got one solution. So I want you to think right now, are there any equations that will not give us exactly one solution? Write down any thoughts you have on that right now in your notes. One? Like what? There's sometimes when we had like x squared, right? And that had, like if x squared equaled 4, x could equal 4 or negative 4. So our squares, that's kind of in that line of Pythagorean theorem where we were looking at answers. Has anyone ever seen something like this where it says x is greater than 4? Is there more than one answer to that? Yeah, there'd be 4.1. There's infinitely many answers, right, that make this true, right? So if we look at this, that's an inequality. That's not an equation. So this one is an equation because it has an equal. This is an inequality. So what we're going to look at today is some different ways of solving. So when we're solving these, you're going to come up with some weird solutions. So take a look at this first example and please write the problem out right down here. We're going to put x plus 1 is equal to x plus 2. Do you have your notes? So when we look at this problem, first step is we want to get Lucy all the x's on one side. What are you going to do to get rid of the x's, get them all to one side? Minus, because this is actually what? 1x, right? So we can minus 1x from both sides. And Cody, if I do that, what am I left with?
1 plus 2.
1 is equal to, what do you have on this side?
Just 2.
Just 2. 1 ever equal to?
No, it does.
No. This is a false statement, okay? You do not get to put down false statement for your answer. And we're going to talk about what you will be writing for your answer. But you want to solve a problem. You're always going to get rid of the variable or get the variables over to one side. And I'm going to have you wait. I'm going to show this video. And in this video, they're asking you to write down here, right? They're going to ask you to summarize the video. And the key thing that I want you to summarize is what happens when we get this false statement, okay? So we're going to look at this video. It's a little loud, but...
Kind of like a normal equation. But look at what happens when we try to solve for x. Let's move this s to the right-hand side of our equation.
To do that, we subtract x from both sides.
And then on the left, these x's cancel out, and we're left with 4. On the right, these x's cancel out, and we're left with 2. All of a sudden, we're left with two numbers that do not equal each other. 4 does not equal 2. This is a false statement. If you get a problem like this, where the variables cancel out and you're left with a false statement, you have a problem that has no solution. In this case, no value for x will ever give you a true statement. To see that, let's look at another example. 10 plus 6x equals 15 plus 6x. Again, this looks kind of like a normal equation. But this is in fact a problem that has no solution. No value that you plug in for x will ever make this statement true. To see that, let's pick a couple values for x and see what happens. So let's pick x to be 2. So we get 10 plus 6 times 2, and we want to know if that equals 15 plus 6 times 2. Well, simplifying, we get 10 plus 12, and does that equal 15 plus 12? 10 plus 12 is 22, and 15 plus 12 is 27. 22 does not equal 27. We get a false statement. So that means our value for x, 2, does not work. But what if we pick a different value for x? X equals 6. Let's see what happens then. We get 10 plus 6 times 6, and does that equal 15 plus 6 times 6? Well, we have 10 plus 36. Does that equal 15 plus 36? 10 plus 36 is 46. And 15 plus 36 is 51. 46 does not equal 51. Another false statement. So, this problem has no solution. No matter what value we pick for x, whether it be 2, 6, 105, we will never get a true statement.
So, when we are looking, if we are going to summarize that video, whenever we are looking and we get a false statement where it is not true, what would we say the answer is going to be? No solution. So, here's what I want you to write down. When you get a false statement, it means there's no possible solution. You will write no solution. So how you're going to write this answer is you are going to write x equals, so write this that I highlighted down there, x equals, and we are going to put no solution. Okay? Anytime you get a false statement, x equals no solution. What we are looking at. Now, the other case, and so it doesn't matter what number I put in. If I put in 7 here, 7 plus 1 does not equal 7 plus 2, 9. Never going to be true. It doesn't matter what number I pick, it will always be false. If you turn to the top of the next page of your notes, we are going to start, Timothy, with using the distributive property here. So if we're using the distributive property, what would you tell me to write down? 2 times x, or 2x, plus 2 times 3, which gives us 6, and Other side of the equal sign was 6 plus 2x. So Elijah, as we are looking at this one, we have to top up here, go up here. As we look at this one, we want to get all our x's on one side. So what would you do to get all the x's on one side? How do I get rid of 2x? Elijah.
What?
How do I get all the x's on one side? What do I have to do?
Minus 2x.
Minus 2x. Once I'm minus 2x on both sides, I am going to be left with 6 equals 6. This is a definite true statement, wouldn't you say? We are not going to watch the video on this because the key thing with true statements, they are going to tell you is that x is equal to, you're not going to say true, you're going to say x equals all real numbers. 100 question. Okay. So you're going to write down all real numbers. Dallas, is your pencil working right now? So do you write that down? X equals all real numbers. I will always need to see that you get to this point where 6 equals 6. Now next year about this time, you guys will be solving systems of equations in algebra. When you solve systems of equations, you'll get one answer like we did, x equals a certain number. You're going to get no solution like we just got, and then you're going to have infinitely many. We will be doing systems of equations this year in about 3 or 4 months. You will have these same type of things. So these equations, they just keep coming back. Question?
You just put x equals AR in.
No. You could use a mathematical symbol that looks like this. And this symbol with that 2 lines and an R means all real numbers. But you cannot use ALN or ARN. So here's what the video says. If you have a true statement, okay? If you have a true statement, write this down with me at the same time so I don't have to wait, Hunter, till later. If you have a true statement, meaning 7 equals 7, 0 equals 0, -8 equals -8, right? Our answer to the problem will be x equals all real numbers. You must show me that you got one of these solutions, though, okay? So as we are looking at that, we are going to do a couple of the questions down below. And then we're going to get you started on your homework. And we cut back on the 12, you only are doing the 18, so they're doing really 9 or 10 questions instead of 18. So we're going to start with this first one. Remember, we need to get rid of this parenthesis on this side, and I'm going to have someone help me on the other side. That means we're distributing and multiplying. What am I going to get when I take 2 times 3x? 6x. Keep going. And now I'm going to take 2 times that minus 3. I'm going to end up with a minus 6 plus 4. Be ready and please add the like terms on this side. Equals. On this side, if I am distributing, I am going to be looking, Kaylee, at what? If I distribute on this side.
6x.
6x
And -2.
minus 2. When you added your like terms on this side, Ellen, what did you end up with? Purple. So, we might want to rewrite this instead of this just as being, because this is -6 and -4. We actually have a -6 plus 4. What am I going to get if I had -6 plus 4? We're going to end up with -2. So I could put a plus -2. And on this side, I have 6x minus 2, right? So you always want to simplify first. So Riley, once I've simplified that, I now want to get x is only on one side. How do I get rid of the x on one side? Which x, should we get rid of this x? How do you get rid of? Subtract. We're going to do it on this side of the equal sign and on this side. When I do that subtraction, Sean, what am I left with? So on this side, I'm going to have -2 equals -2. I am not going to put that it's a true statement, even though it is. My answer is going to be x equals, and if you like using that symbol, all real numbers. Okay? All real numbers. Okay? You gotta have like 2 lines with an R. Kind of like a capital R, but mathematically, if you just put an R, it's not really real. It's gonna be like a double.
Yeah.
I guess. Or double R. Okay? So, are you ready, Jerica, to start the next question? We're going to add the like terms on this side. So I'm going to add 6x and what? -2x, right? Okay? And when I do that, what should I end up with? Okay? So if I'm adding my ones in green, and for some of you, sometimes either the highlight or underline, that is going to give us equaling 4x, right? And then Hunter, if we're adding the ones in yellow, the -4 plus 8, going to get 4, okay? Next step, Isaac. Got to get all the x's on one side. How?
Subtract -4x on each side.
Do you want to subtract -4x or just subtract 4x? Because subtract, right. Because if we subtract a negative, right, that's the same as adding 4x, okay? So in this case, we're subtracting that 4x. We're going to do it on both sides, okay? And we end up with an answer in that one, Zach, of getting what?
-12 equals +4.
True or false?
False.
Definite false statement, right? So we're going to say x is equal to no solution. Question.
Could you just do like x is equal to false?
Nope. No, you need to write out no solution. I know. The extra lead that some of you have to use for this, I know it's atrocious, but all right. So, Johan, we're going to start this next one. Adding your like terms on both sides. So on this first one, can you help me add my like terms on this side?
Oh, yeah.
Okay.
So it would be 5x.
Okay. Yep. And some of you aren't showing the work, like subtracting the 4x on both sides like I showed it. I want you to show, and in your notes, I want you to copy it exactly as we are doing it. All right, so we're on the other side, and Addie, what'd you get on the other side when we add our like terms? 8 plus 3x. This isn't going to be one of our special answers, right? Connor, what do you need to do? You got to write this down. I need the work on your notes. So what are you going to do? You've got to get all the x's on one side. Yes, you can.
You are to subtract 3x.
Right. Smaller one we're always going to get rid of. So we're going to subtract 3x on both sides. Okay? Once I do that, Janessa, I'm going to be looking at what?
2x plus
8. Okay, Dallas, next up. What do we have to do?
Then you have to subtract 2
Subtract 2.
from both sides.
Both sides of my equal sign. So a lot of you kind of, sometimes on your quiz, you combined some steps together and did some stuff, and it caused you to make some very silly mistakes. So we're going to get this answer. We're going to divide both sides by 2, and we get x equals 3. And on the quiz, you had to check. Who has no clue how to check? We kind of talked about this. Who was just like, nope, don't get it. Don't get it, right? Okay. I got 3 or 4. Hunter is going to start us out. And when we check, we want to go back to the original problem. And what it means, write this on your notes, especially those of you that don't get how to check. Check. Original problem, substitute. Instead of using x, you're going to put 3. So where the equal sign is, Hunter? That's going to be our question. That's what we're trying to figure out. So start me on this side of my equation. Any place where there's an x, you're going to put in a 3. Tell me what to write down. Because you're going to write this on your paper also.
3 times 3 plus 2 plus 2 times 3.
Okay, we're going to stop at that point, right? Does that make sense? Every place where there was an x up here, we replaced it. So I don't even need my calculator for this, right? 9 plus 2 is 11. 11 plus 6 is 17. If I wanted to plug that whole thing in my calculator, I could. Okay? Ramiro, on the other side, tell me what I should write.
I had a question.
Okay?
Does it have to be in that order?
Well, see, that's how the original problem was. It was 3, and I just changed, instead of putting this x, I put a 3, and then I kept it 2, and then I kept it. So yes, you want to keep it in that exact order when you do it. Okay? So now on this side, Ramiro, help me, tell me what I should write down.
I don't know. I
Start
said
with
I
what-
didn't know how to do it.
Start with what you see right behind the equal sign. What do you see right behind the equal sign?
2,
2, and then what?
3,
Plus.
6.
Wait. You see a 2 plus, don't you?
Yeah.
Okay, so you got to tell me exactly what to write. 3,
X.
and then what? We don't want x. What did we say we're going to do? Any place where we see an x? Any place?
3.
We're going to put in a 3. So you have to tell me, so start from the beginning. 2, right?
2 plus 3 times 6.
Wait. Why 6? What is x equal to?
Because you said what's in order, and there's a 6.
Yeah, but there's an x here first, right?
Yeah.
Okay?
Oh, I thought.
So any place, so this x, I'm not going to put an x there. You're going to put the 3. That's
I
going to be
thought you
what?
would replace the 3.
I'm not talking. I know, but you're laughing. Weren't you? No. Or was it Dallas laughing? Good. All right. So keep going, Ramiro.
And then 6.
And then what 6?
6.
Plus 6, not just 6, right? You can't just write this with nothing here, right? So this
Well, I
original.
thought you would put it. That's
Well,
what
I was
said.
asking you to tell me what to write down. Have you written this in your notes?
No, because
Do so. Do so. So now, okay? So now as I'm looking at this, I am going to either do this in my calculator or in my head. 2 plus 9 is 11. 11 plus 6 is, it checks. On the quiz, the check counted for a point. There was many of you that didn't do it. So instead of 15 out of 15, you got a 12 out of 15, right? I needed you on that quiz to show the check. I needed you to make sure you know how to do this. I would like you right now to do this problem right here. Get all the x's on one side. So we subtracted 4x on both sides, and we got 7 equals 7, which then tells us that x is equal to all real numbers. Okay? So, in your homework, questions 1 to 18, you are doing the odd. So, here's my hint. Totally cross off like number 4, because we're going to do number 1 together. Totally cross off number 6 so that you have enough room so that question 1's work can go all this whole length, right? So you got enough room because you're crossing off, okay? So when you start with question 1, and then I'm going to hand back your quiz. First step, if I am starting this, what are you going to do first as I look at the problem? So as you're looking at those, I don't care if you're crossing off, however you do that. Nolan, what do you want to do first in number 1? Add 2 ends. We always want to add our smaller ones. So we're going to add 2 ends to both sides. Okay? What am I left with when I do that, Timothy?
I'm left with 5n plus 2.
5n plus 2 equals negative 8. Next step. What are we going to do, Riley?
You're gonna subtract 2 from the negative
I'm going to subtract 2 from negative 8. Now, subtracting 2 from negative 8, what I might have a hint for some of you, that is actually the same as adding a negative 2. Do you agree? 2 plus negative 2. So especially on this side, it's negative 8 plus negative 2. That is going to leave us, Haley, with how much? Negative 10 is equal to 5n. How am I solving this? Next step, Johan.
You divide by 5.
So since I have this problem, I'm going to write it down here. I'm going to put 5n divided by 5, and I'm going to put negative 10 divided by 5. And I get n equals negative 2. And I think, oh man, I know there's this huge quiz Thursday, and I should make sure I know how to check it. So, Dell, let's start us off with the check.
So you want to do 3
Okay?
times negative 2,
Yep.
and then you want to do
Back
plus 2.
plus 2. So at that point, I have negative 6 plus 2, right? That gives me a negative 4. Now I'm going to check the other side. So that's the question mark. And now I would write down what, Chastity? To continue my check. I put negative 2, what?
I'm not sure.
Chastity. I'm sorry. So I'm going to put negative 2 and then what?
Times negative 2 minus 8.
And if I put this in my calculator, negative times a negative is positive 4, right? And 4 minus 8, do I get the same thing on both sides? So I get negative 4. That's how you do the check, right? This comes out to be negative 4 on both sides. So this answer is right. So by doing the evens, crossing off the evens, you should have enough room to show the work for each problem. Now some of them you're going to get an answer. Not all of them are going to be all real numbers or no solution. So show your work, okay? As you are working the rest of the time,